Guys, this is the video for Unit 1, Day 2 notes in Math 1. So this is our first official Math 1 unit. Last unit was a lot of review stuff, but this unit really gets into some new Math 1 concepts. Our objective in this video is to be able to identify arithmetic sequences and then write a recursive rule for them. And your objective in that, your learning objective or language objective really, is that students will be able to find a pattern and determine if the pattern is arithmetic, then use that information to write a recursive rule. I'm actually going to skip the front page of these notes. I want us to do those examples together in class. You might try and do them on your own now, but I'm going to skip them for now and move on to the back side. So this is just the notes that you're going to fill out and have ready to go, and then we'll work more of these examples in class. So an arithmetic sequence is simply a sequence that adds, and therefore it will have a common difference. So just like we did yesterday, we are going to be looking at these terms and figuring out how they're changing. So when we look at number 6, to get from 3 to 8, we know that we need to add 5. But we always want to make sure that it works for all of the terms. So 8 to 13, we also add 5. 13 to 18, we add 5. And 18 to 23, we add 5. So our common difference here is what we are doing, and that is 5. Whatever you're adding is what is your common difference. If you're unsure or can't see it right off the bat, you can always do the second term minus the first term. So whatever the second term is minus the first term will always give you the common difference. So 23 plus 5 would give us 28. And then 28 plus 5 would give us 33. And 33 plus 5 would give us 38. Looking at number 11, we can see that this sequence is going down. 11 is bigger than 9. And we know that 11 minus 2 gives us 9. And 9 minus 2 gives us 7. 7 minus 2 gives us 5. And 5 minus 2 gives us 3. So our common difference is -2. If you were doing our little handy trick that we wrote over here, you would be doing 9 minus 11, which would still give you -2. So 3 minus 2 is 1, 1 minus 2 is -1, and -1 minus 2 is -3. You always want to remember that it keeps the trend. If it was going up, it should continue to go up. If it was going down, it should continue to go down. Looking at number 8, we'll do one last one together. To get from 3 to 1.5 is a little bit tricky. So you might come over to the side and say, okay, 1.5 minus 3, and that is equal to -1.5. So we are going to be minusing 1.5 each time. And we just check to make sure it works. 1.5 minus 1.5 is indeed 0. 0 minus 1.5 is indeed -1.5. And -1.5 minus 1.5 is indeed -3. So we know that it works for all of our terms, making the common difference -1.5. The next 3 terms will then be -3 minus 1.5, which is -4.5, -4.5 minus 1.5, which is -6, and -6 minus 1.5, which is -7.5. You guys try and do 9, 10, and 11 on your own, and then come back to check your work. As you can see here, for number 9, we found a common difference of -8, with the next 3 terms being -28, -36, and -44. Number 10 had a common difference of 2, so it had the next 3 terms -11, -9, and -7. And lastly, number 11 had a common difference of -20, so the next 3 terms were 20, 0, and -20. Notice we only put a sign if it's going down to tell us that it's negative. If it's positive, there's no need to put a plus, and we just leave it there as a positive number. Going along with arithmetic sequences, we have a recursive formula, and that's just a formula that defines each term in a sequence based on the previous term. It must always state the first term along with the change. So whatever it's changing by needs to be there. You also need to have a starting term. So, for example, 8, 10, 12, 14, 16 is our pattern. We can see that we are adding 2. So when we tell the rule and we write our recursive rule, we are going to add 2 starting at 8. Really, your starting number can be any term in the sequence as long as you have a starting place, because then you can go backwards and forwards. So in these examples, I'm going to give you the recursive rule, and then you need to write the first 5 terms of the sequence. So looking at number 12, it's telling us that we need to add 5 starting at 12. So the starting number always goes in the first blank. It's the give me. It's the easy number. Then from there, we're going to add 5 to get the rest of our terms. So 12 plus 5 is 17. 17 plus 5 is 22. 22 plus 5 is 27. And 27 plus 5 is 32. In number 13, it says to add negative 8, starting at 15. So adding negative 8 is the same as subtracting 8. So we're going to start at our starting term of 15 in the first blank. Then we're going to minus 8 each time. So we're going to go 15 minus 8 is 7. 7 minus 8 is negative 1. Negative 1 minus 8 is negative 9. And negative 9 minus 8 is negative 17. You guys try and do 14 and 15 on your own and then check back to see your answers. So you can see for number 14, we started at negative 4, adding 6, it got us negative 4, 2, 8, 14, and 20. In number 15, we needed to start at negative 8 and add negative 2. So we have negative 8, negative 10, negative 12, negative 14, and negative 16. Even though I'm telling you to add, since you're adding a negative number in 13 and 15, those sequences are actually decreasing sequences, even though we say we're adding. Because remember, adding a negative is the same as subtracting. This last piece, you're going to go backwards. So I'm going to give you the sequence, and then you're going to write the recursive rule. Remember, you'll always say what to add and where to start. That is your shell that you will fill in each time. So, looking at number 16, to get from 3 to 8, I know that I add 5. That works to get from 8 to 13, and from 13 to 18, and from 18 to 23. So I know that I'm going to add 5 starting at 3. It's very important to make sure that you write the entire piece there. You need what you're doing and where you're starting. If you don't give a starting point, then you can't make a distinct sequence. Lots of sequences add by 5, but this is the specific one that we wanted, so we have to have a starting point. So looking at number 17, to get from 11 to 9, I minus 2. You might have noticed that these sequences are the same as the sequences at the top of the page. I did that on purpose so that you wouldn't have to keep doing the math over and over. So since we knew that 17 was adding negative 2, we'll just add negative 2 starting at 11. So what do we add and where do we start? Number 18, we were going from 3 to negative 1 from 3 to 1.5 is minus 1.5, and 1.5 to 0 is minus 1.5. So we are adding negative 1.5 starting at 3. You guys fill in 19, 20, and 21, and then check back to check your answers. In number 19, you see that we needed to add -8 and then start at 12. Number 20, adding 2 but starting at -19, and number 21, adding -20 but starting at 100. You could flip it around and say start at this and then add this, whichever one makes most sense to you. Tomorrow in class, we'll do some more examples with this, and I will answer some more questions that you may have. And until then, just go ahead and put some questions in the question bubble in just a second, and I will be sure to get to those in class tomorrow. See you then.